Okay, so in this lesson, we're going to discuss properties of special parallelograms. We finished talking about properties of parallelograms, but now if we add additional shapes, such as a rhombus, rectangle, and square, those are parallelograms that have special features. We see that a rhombus is a parallelogram that has 4 congruent sides. We see that a rectangle is a parallelogram that has 4 right angles. And we see that a square is a parallelogram with 4 congruent sides and 4 right angles. Also, a square is a parallelogram that is both a rhombus and a rectangle. So now that we have these new definitions for special types of parallelograms, let's look at some of the tests that we can apply to identify them. We have the Rhombus Corollary, which states that if a quadrilateral is a rhombus, then it has 4 congruent sides. So if you find a quadrilateral with 4 congruent sides, then opposite sides are congruent. So 4 congruent sides implies opposite sides are congruent, which makes it a parallelogram. So a quadrilateral with 4 congruent sides is a parallelogram, or more specifically, a rhombus. So we do not need to be told that it is a parallelogram first. Just being told that it is a quadrilateral, quadrilateral has 4 sides, and that all 4 sides are congruent, that is enough for us to say it is a rhombus. That is enough for us to say it is a parallelogram. The rectangle corollary states that if a quadrilateral is a rectangle, then it must have 4 right angles. So again, opposite angles are congruent. So 4 right angles implies opposite angles congruent. So this quadrilateral must be a parallelogram. But more specifically, it is a rectangle. And we always want the more specific answer, the more precise answer. Yes, it is a parallelogram, but we want the more specific answer, say that it is a rectangle. Or in our last example, yes, it is a parallelogram, but more specifically, it was a rhombus. The square corollary states that a quadrilateral is a square if and only if it is both a rhombus and a rectangle. Or the alternative way of saying that is a quadrilateral is a square if and only if it has 4 congruent sides and 4 congruent angles. So you can work this out either way, but you have enough information to show that it is a parallelogram. But more specifically, it is a square because it has 4 congruent sides and 4 right angles. So in our first example, it states that for any rhombus QRST, decide whether the statement is always true or sometimes true. It says draw a diagram and explain your reasoning. So QRST, we have to follow the order of the letters when we draw it. So Q connects to R, connects to S, connects to T. And angle Q and angle S are opposite each other and congruent. So that will always be true because opposite angles will always be congruent. So we'll say always true. And we'll look at the next one where we say, well, angle Q and angle R, they are not opposite angles, they are consecutive angles. And the only time that will be true is if QRST is a square, because we said a square is a type of rhombus that is also a rectangle. So this is sometimes true. Only true when QRST is a square. A square is a rhombus. That is also a rectangle. So in example 2, it says classify the special quadrilateral and explain your reasoning. Well, we see that we have 4 congruent sides. So at the very least, it is a rhombus. And then we have a 70-degree angle, so it's not a rectangle. But we know that a rhombus makes it a parallelogram, so opposite angles must be congruent. And in a parallelogram, consecutive angles are supplementary. So this angle at the bottom must be 110 degrees. This angle at the top must be 110 degrees. And that means it is a rhombus. If we found that we had at least one right angle, that would be enough for us to say it is a square, because opposite angles would be congruent and consecutive angles would be supplementary, and it would give us 4 right angles. So we have a theorem here called the rhombus diagonals theorem. It states that a parallelogram is a rhombus if and only if its diagonals are perpendicular. So if we can show that there is a right angle where the diagonals meet, then that would make it a rhombus. I just want to emphasize that we start with the fact that we know it's a parallelogram first, and not just the word quadrilateral is being used. Another rhombus theorem is a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So notice that these angles are cut into equal smaller parts, and then the other set of opposite angles are cut into equal smaller parts. So we can use these theorems with rhombus to find the measure of all the angles in this drawing. Example 3 says find the measures of the numbered angles in rhombus ABCD. They're already telling us it's a rhombus. So since they're already telling us it's a rhombus, what must be true about angle 1? And the first theorem that we learned was that the diagonals in a rhombus are perpendicular. Therefore, the measure of angle 1 must be equal to 90 degrees. The other theorem we learned is that diagonals bisect opposite angles. So we know that both of these angles are 61 degrees, and that angles 2 and angles 3 must also be 61 degrees. Now we can take the triangle that is formed using the diagonals, and we can find angle 4. So 180 degrees minus 90 minus 61 will be equal to the measure of angle 4. 29 degrees is the measure of angle 4. So we use the perpendicular diagonals theorem to get angle 1, and we use the fact that diagonals bisect opposite angles to get angles 2 and 3. And then we use that there is 180 degrees in a triangle to get angle 4. The rectangle diagonals theorem states that a parallelogram is a rectangle if and only if its diagonals are congruent. So AC is congruent to BD, and the drawing goes a little further and shows you that if I were to put a point X here, that DX is congruent to XB, and we can say that AX is congruent to XC, and this comes from the parallelogram theorem that diagonals bisect each other. Remember, it started the theorem by saying a parallelogram is a rectangle. So it means all of the parallelogram properties apply, and that's why they were able to put these tick marks here, saying that they are congruent because the diagonals bisect each other, and these are also congruent because in a rectangle, diagonals are congruent. So in example 4, it says you are building a frame for a window. The window will be installed in the opening shown in the diagram. Part A says the opening must be a rectangle. Given the measurements in the diagram, can we assume this and explain? And we see that opposite sides are congruent. But is that enough to say it is a rectangle? And the answer is no, we cannot assume this. Right now, we know it is at least a parallelogram, and that's all. So how do we show that a parallelogram is a rectangle? Well, we can either use the definition and show that we have 4 right angles, or we can use the theorem and show that the diagonals are congruent. Part B says if you measure the diagonals of the opening and the diagonals are 54.8 inches and 55.3 inches, what can you conclude about the shape of the opening? Since diagonals are not congruent, it is not a rectangle. Okay, so our first part A statement that is at the very least a parallelogram. Now that we've shown it is not a rectangle, it is a parallelogram. There are no right angles because the diagonals are not congruent. Example 5 states that in rectangle QRST, once they say that, they are telling you it is a rectangle, so the properties of a rectangle will apply, and you can use those properties to solve. It says QS is 5x minus 31, and RT is 2x plus 11. Since QS and RT are diagonals of a rectangle, we can say they're congruent and set the algebraic expressions equal to one another. And when we solve, we get that x is 14. It says find the lengths of the diagonals. So we want to plug 14 back in. We can say that QS is equal to 5 times 14 minus 31. That gives us 70 minus 31, which is 39. And if you plug that in for RT, you should get the same answer. 2 times 14 gives us 28. 28 plus 11 is 39. Example 6 says decide whether the parallelogram ABCD with the vertices given here is a rectangle, rhombus, or a square. Give all the names that apply. So we'll start by plotting these points. So we've got a shape that we're being told is a parallelogram. We can verify it by checking slope. So we don't need to check that it's a parallelogram. They're telling us that it is. But just to be thorough, we'll say the slope of AB. If we start at A, we go up 1, 2, and we go to the right 1, 2, 3, 4, 5, 6, 7, 8. So rise over run is 2 over 8, or 1/4. The slope of DC, the opposite side, we can go up 1, 2, and then right 1, 2, 3, 4, 5, 6, 7, 8. We see that is 1/4. So these are parallel. And then we'll do the slope of AD. From D, we go up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2. 8 over 2 is 4. And the slope of CB, we start at C, we go up 1, 2, 3, 4, 5, 6, 7, 8, and over 2. 8 over 2 is 4. These sides are parallel. We have a four-sided figure with opposite sides parallel. It is a parallelogram. Now we can go on and analyze what type of parallelogram it is, which of the more specific names, rectangle, rhombus, or square, which would best apply. So as we continue to analyze this quadrilateral ABCD, we want to determine which of the special parallelograms it is, and the quickest and easiest way to do this is through the diagonals. So if I draw diagonals in here, there's diagonal BD and diagonal AC. And you could go through other tests. You can say, well, let me check all 4 of the angles for right angles for a rectangle. Or let me measure all 4 of the sides to see if they're congruent for a rhombus. You can do that, and you'd be able to get to the right answer. You can do it quicker just by analyzing the diagonals. So the theorem for the diagonals of a rectangle is they must be congruent. And the theorem for the diagonals of a rhombus is they must be perpendicular. So let's run through these tests. First, we'll check if it's a rectangle. So the measure of AC is equal to the square root of, we'll take A and C, and we'll find the difference of their x values, -2 minus 4 squared. Add that to the difference of their y values, 6 minus 0 squared. And we get -6 squared is 36, plus 6 squared is 36. It is the square root of 72. And then we say, well, let's look at BD. The measure of BD we'll take the difference of the x values, so 6 minus a -4, and square that, and add it to the difference of the y values, 8 minus -2, and square that. We get the measure of BD. 6 minus -4 is 10. 10 squared is 100. 8 minus -2 is 10. 10 squared is 100. So we get the square root of 200. So we see the diagonals are not congruent, so it is not a rectangle. Next, we want to check the slope of the two diagonals. So we can say slope of AC, and we can count that. We see that we're going 1, 2, 3, 4, 5, 6 down, and 1, 2, 3, 4, 5, 6 over. So it is -6 over 6, which is -1. And we can look at the slope of BD, and we can count from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 over 10 is +1. Because they are negative reciprocals of each other, they are perpendicular. AC is perpendicular to BD, and that would make it a rhombus. And for it to be a square, it would have to be both a rectangle and a rhombus, so it's not a square. And we would say that parallelogram ABCD is a rhombus. So using the diagonals gives us fewer calculations to perform. We see that we only had to do distance formula on 2 diagonals. We only had to do slope on 2 diagonals, and we were able to determine that it was not a rectangle and that it was a rhombus. Again, if we were to measure all 4 sides, we would have had to use distance formula 4 times to find it to be a rhombus. Or if we were to find all 4 right angles, we would have had to do slope 4 times to find all 4 right angles. So we just reduced the amount of calculations that we did, but both ways would be good for analyzing the shapes. All right, that's the end of the video. Take your notes, go back and complete the worksheet, and then do the exit ticket.